Good morning, everyone. My name is Rula Ali, and today I'm presenting about hidden information slash puzzle method. So first of all, I'm majoring in pre-dentistry, and this is my last semester. So hopefully next year I will get in the dentistry school. Anyways, before I start, I just want to ask how many here have taken physics or math? Then the next question is, how many here have struggled with doing problem solving or words problem? So today, by the end of the presentation, hopefully you'll like the method that I'm presenting for. And this is a funny quote about physics. It says light travels faster than sound. This is why some people appear bright until they speak. So what does hidden information mean? First of all, problem solving is an art best understood by practice. Trying to solve a problem or figuring out what the problem is asking you to solve for requires some steps and a lot of time and effort. So especially if you're working with kind of problems that have a lot of variables, terms, and words and numbers. So in my case, I spent hours and hours trying to figure out what those questions are asking me to do, or just to do my homework or practice for my test. So sometimes even it was not clear what the question is asking me to solve for or asking me to do for. So I was totally lost until I found a method called the puzzle method, and I'm gonna talk about it in a bit. So, but first of all, remember, getting an answer is not the only goal you're looking for, but you're looking for a method, and you're seeking to learn physics as you're doing a problem, and also you desire to polish your skills at doing physics. So it is hard and usually contain words like keywords that guide you to the hidden information in the question. So simple steps for words problem. How do we find what is the hidden information? Because this is a major component of understanding the question. So first of all, read the question carefully. I always, especially in the test, I freak out and don't read the question, the whole question. So it's very important that you read the whole question and you see trying to find out the keywords. So second, look for terms that you think it might be part of the hidden information. Also choose a strategy to work with to solve that problem. For example, my strategy is write down all of the terms or variables that in the question and try to match it with the equations. So that way I will list all of the variables that I have, I have numbers in, and the variables that I need to solve for, and try to match it with equations. That way I will get the relationship between the variables. Also, draw a diagram. Drawing a diagram will help you visualize the problem physically, as well as practice a lot. That way your brain will get the method and will get used to what you're normally doing in the practicing. So in the test, you won't get worried too much about what do I do, because your brain is already have been practiced a lot with those questions. Also, remember to highlight what the question is asking you to solve for. So my strategy is called puzzle method. Puzzle method is a bunch of questions you could ask yourself while you're doing a problem, trying to find out what the question is asking you to solve for. So it divides up the question into small parts, and you will answer each question while you're doing the whole, the main question. You ask some questions to find out what the hidden information is and what the question is asking you to do. So it helps you to know what variables you have, what you need to solve for, and how you solve it. Here I have an example I got it from the book. It says a Saturn V rocket is launched straight up with a constant acceleration of 18 meter per second square. After 150 seconds, how fast is the rocket moving? So I underlined the constant acceleration and how fast. Those two keywords kind of gave me a hint that we're looking for like the speed, because it says how fast, and we already have acceleration, which is constant, and we have time. So it says constant acceleration. First of all, let's learn some terminology. What does acceleration mean? So acceleration is the rate of velocity per unit of time. On the other hand, velocity is the speed of something in a given time. So to have a constant acceleration means there is no change in speed, and like it is, that means there is no change in velocity. So we have velocity, initial velocity, and final velocity, because in that question it's asking us to find like how fast, which is the velocity, but it is after 150 seconds. So we are looking to find for final velocity, and we already said that since we have a constant acceleration after like at 150 seconds, that means we have like initial velocity as 0. So we said earlier as like acceleration is the change in velocity over the change in time. Since initial velocity is 0, we solve for final velocity by putting like 0 here, and in the acceleration we have 18 meter per second square plus the time 150 seconds. So final velocity is 2,700 meter per second. Remember to put the right unit for what the question is asking you to do. Why do we care? The question here is like the purpose we're doing that problem, because most of us, like most of the students, struggle with problem words. As I said before, puzzle method helps divide up in the question into small parts. For example, I'm gonna go back to the example here. So to apply a puzzle method, first of all, we ask a question: do I have at least one equation that contains the variable that I have in the question, and do I have another equation that matches the variable that I want to solve for? If the answer is yes, then solve it. If the answer is no, you always have two options. First of all, you look for the unknown variable, and you try to find another equation if you couldn't find like one that matches with the numbers we have in the question. So you look for another equation, or there is another option. If there is no other equation for that unknown, you look for other unknown and see if there is any equation that could match between the numbers you have and the known variables with the unknown variables. So that's why we care, because most of the students struggle with words problem, and it's very hard and confusing, especially with those students who like to memorize, and like it's not about memorizing, it's about understanding the concept, because hidden information is a major component of the problem solving. So it helps you understand the problem better, and it's because by answering each question aside, you ended up getting the right answer at the end. But like as I said before, we're not looking for an answer, because if you just put an answer without showing how you did it, you might not get it right, and you might get a 0. Versus if you put like step-by-step method, you'll get, in the worst scenario, you'll get partial credit instead of getting a 0. So I sat down with my instructor David, and he actually taught me this method. So I asked him about the grades and how puzzle method affected the curve of the grades of the students, and he showed me like a graph. Like he gave me like some numbers, and I graphed it, and here we could see like how the grades is changing, like from 20%, like until 70%, 70-ish percent. So it's pretty much helpful with the students, and because it's like a method, and that your brain is just getting to know it very good, and you divide up the question into small pieces. It's like a puzzle. That's why it's called puzzle method, because you put in puzzle, you put each part in the right place with the right order, or with the right with the parts, because there is a relationship between all of the parts. That's why it has to be in the right order and with the right parts. Conclusion. Words problem are often considered to be the most challenging task in physics or math, with students likely to stumble over the move from the simple formula to applying it in a real context. Following some steps in puzzle method helps putting all the pieces together, and it will make it so easy. However, most students find words problem are so hard and confusing. But if you have a method, you'll find it out that it is easier than you thought. But it needs some practice, and you need a plan or method that you could apply. Words problem involve a bit more than just some basic calculation. Some students who are good in memorizing in physics, physics facts, may not feel comfortable understanding the sentences and concepts used in physics. Word problems can be also very hard and confusing, especially for those students who have difficulty focusing or staying motivated. While doing those kind of problems, they can be tricky or boring. So as I said, doing it piece by piece will help you a lot, getting the major component, which is the hidden information. And lastly, you have to perform the calculations correctly, and that way you'll get the right answer, you'll get the concept, and you'll understand the question very well, and you'll find math and physics they are so fun and easy. And I have a short video here. This is another method. If you didn't like puzzle method, this is another basic method you could watch, or you could find it on YouTube, or you can do your own method by doing physics problems. So let's just watch this really quick.
Hello everyone, I'm Jesse Mason, and in this installment of Teach Me, we're going to learn how to solve any physics problem. Now that's a bold statement, I know, but the method that we outline here is so useful that it can and should be used for each and every physics problem that we encounter. Okay, so here's a handy way to remember our problem-solving method. Yeah, it's a little childish, but as Eric Domain said, it's not that little children are scientists, it's that scientists are big children. So our problem-solving method comprises 5 steps. First, draw a picture. Second, knowns and unknowns. Third, equation. Fourth, solve symbolically first. And fifth, check your answer. At the end of this video, we'll monkey around with a somewhat absurd but memorable mnemonic device for these 5 steps. So stay with us. Now, before we elucidate each of these steps, it's worth noting that there's kind of a 0th step in our problem-solving method, and that's to read the problem carefully. Don't forget to do that. All right, first official step. Draw a picture of the body or bodies in question. Even if our artistic sensibilities have stagnated since 2nd grade, we still need to draw a picture in order to visualize the situation. Be sure to include the surrounding environment in the picture, noting any motion that's occurring. Are there forces at play? If so, then we'll need an additional depiction, namely a free body diagram. Last but not least, we need to select a coordinate system and include it in all of our drawings. Step 2. List the knowns and unknowns relevant to the problem. We will likely need all of the numerical values given in the wording of the problem, and possibly a few more from an appendix or a Wikipedia entry. These numerical values will be implemented in the 11th hour of our problem solving. Step 3. Select the appropriate equation for the problem. This step is the crux of physics problems, and for green physics students, pardon the etymological pun, the vein of their studies. I can't count the number of times I've been asked, Professor Mason, which equation do I use? Alas, there is no silver bullet for choosing the right equation. One must first understand the conceptual underpinnings of the equations and their relevance to the problem, which really only comes with practice. Which is why practicing physics is so important to understanding physics. Of course, if a problem really has you flummoxed, a last-ditch attempt at equation selection can be made with trial and error. Step 4. Solve the equation symbolically first. Numerical values should only be inserted once the equation has been solved for the unknown. Terms will often cancel, simplifying solutions, and much physical insight about our world can be gained from delaying the gratification that comes with plugging and chugging. Oh, and don't forget the units when inserting numerical values. Units are such an important and helpful aspect of problem solving that forgetting them is practically an unpardonable sin. It's like I always tell my students, you take care of your units, and your units will take care of you. Step 5. Check your answer. No, I don't mean by looking in the back of the book or Googling for solutions. I mean by asking yourself, does this answer make physical sense? Are the units what we'd expect? Is the numerical value physically reasonable? If the answer is negative, does that make sense? Asking and answering these questions is just as important as any other step in the method and will put us on the path to a solid understanding of the material. Now, you may be asking yourself, how am I going to remember these 5 steps? Well, assuming that fingertip tattoos are out of the question, I proffer the following mnemonic device. Donkey Kong eats stray cats. No, it's not very humane, nor is it even accurate. Everybody knows that DK is a strict bananivore. But such a hilariously graphic mnemonic device is pretty hard to forget. And that's the mark of a good mnemonic device. So there it is. Draw a picture, knowns and unknowns, equation, solve symbolically first, and check your answer. Donkey Kong eats stray cats. I'm Jesse Mason. I hope you find this problem-solving method as helpful as I do, and that you employ it.
So as we saw in the video, it's kind of similar to my method, puzzle method. So it's just like you select a strategy and you try to practice with it before the test, because in the test we're under pressure, so we just want to practice a lot, and hopefully you'll like it and you won't struggle anymore with physics or math. I have a reference here in my presentation, but anyways, yeah, that's the end of it. Do you have any questions? Yeah, I use the method a lot, and it helps, as I said earlier, because it divides the question up into small parts. So by asking what do I have in the question? What variables, what known variables do I have? What numbers, what unknown variables do I have? What equation that if there is a relationship between the known and unknown, what equation should I use? And it's like it takes a little bit of time, but by practicing and practicing, I got it a lot, and I got the method and I applied it in the test, and I just find it it's so easy and helpful. Any question? Yeah.
What made you choose this project?
Because I found that there are a lot of people who are struggling with physics and math. A lot of students, if you ask them what's the hardest subject you've ever learned, and they said math or physics, especially words problem. And honestly, because I struggled a lot with my words problem and with my physics, and until my instructor taught me that method, when I applied it, I found it's so helpful, so I wanted to share it with you guys. So hopefully you'll like it, and even if you don't like it, you could find similar method that you like and you apply it, and hopefully you'll get it and be good at it. Yeah, so actually my instructor taught us in the class about this method, and some of them have used it and some of them have not, but I always tell my friends that there is a method, and that's why I'm presenting right now, to share it more and more with people, even like the people I don't know, but hopefully like they will get the idea of liking physics and math, because it's the major thing is practice. That's the only thing I found it so important to do with math and physics. Any other questions? Thank you very much.